Hello, welcome to the OneClass channel. My name is Marlin. I'm a second year student at the University of Waterloo studying chemical physics and math. Today I'm going to be working through some high school level and college level chemistry problems. Be sure to check out the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, so for our first question, we would like the full electron configuration for a ground state nitrogen atom. And so, to begin answering this question, we need to understand how to get the electron configuration. Ground state nitrogen. So the electron configuration is notation that displays sorry, just one moment. My apologies about that. Okay, so we need to understand what the electron configuration really displays, and it is notation that displays an atom's so it displays an atom / ions / molecules electron distribution in atomic or molecular orbitals. Okay, and so there are three main principles that govern how we're going to distribute these electrons inside of these orbitals. Three main rules is how we can think about them. And so first and foremost, we're going to have the Aufbau principle. And that one simply states that electrons occupy orbitals of lowest energy first. The second principle is going to be the Polyexclusion Principle. And that one simply states that no two electrons can have the same four quantum numbers. And so you can think of this as the address for the electron, and no two electrons can be basically at the same exact spot or occupying the same, occupying the same spot. And so what this usually will imply is that two electrons can occupy an orbital, but to avoid violating this exclusion principle, they will have opposite spins, so that their last quantum number is different. So they would have spin of 1/2 and spin of -1/2. Okay, and then the last one is Hund's rule. And that one just states that every orbital should be singly occupied before any is doubly occupied. And this is just to minimize the energy, because let's say we have 3 orbitals like this, and I begin by filling. So Hund's rule would dictate that I need to fill them all individually first before I come and I add another electron. And this is just to minimize the energy of the configuration of electrons, so that way we're building up kind of in the same way as the off-board principle. So all of these rules are just so that we can fill in a manner in which we get the lowest energy state, which is the ground state of the nitrogen atom. And so the majority of these principles can be executed if we follow Madelung's rule, which can be illustrated as such. Okay, and so how we're going to fill it is you always fill 1s first, and then 2s, and then 2p and 2s, followed by 3p and 4s, and then 3d, 4p, 5s, 5d, 5p, 4f, 5d, 5f. And so let's write that out. So it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Next up is 5s2, so I'm just filling this way, 4d10, 5p6, 4f14, 5d10, and then 5f14. So this is how you fill it. So depending on what atom we have and where it stops on the list, so for example, it has 4 electrons, I'd be stopping 1s2, 2s2, and that would be the configuration for the lowest, for the ground state of the atom. And so the great thing is that this is captured pretty well in the periodic table. So if we actually read along the periodic table, you'll get the same order that is dictated by Madelung's rule. And so we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 4f, sorry, I had failed to include the 6th row here. If we are supposed to be counting it properly. 6D, 6F. So let's just extend these. So that one stops there. This one looks like that. This one looks like that, and that one looks like that. And so we will have 5P6 indeed. And then 6S2, followed by the 4F14. 5D10, 6P6. Let's stop there because this would involve other things below it too. So just as I said, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, and then we have 6S2. We'll enter the lanthanides with 4F14, and then 5D10 here, and then 6P6, and so on and so forth. So you can either use Madeline's rule to fill it in, or you can use the periodic table itself. And so now let's figure out the electron configuration for nitrogen in specific. And so we're looking for nitrogen. If we just look at the periodic table and where it is, we can see that it has 7 electrons. And so if we were to follow Madeline's rule, we just count until we have 7 electrons. So we have 2, 4, and then this would enter 10 category. And so we're just going to subtract off the extra 3 electrons, and it should look like 1s2, 2s2, and then 2p3, not 6. That way they can add up to the 7 electrons. So if you count it down on the periodic table, 1s2, 2s2, and then 2p1, 2, 3. So 2p3 to get to nitrogen. If you wrote in the 6, it would be neon. And so that is going to be the electron configuration for ground state nitrogen.